All right, I'm going to use the board. Int I equal to 4, float A equal to 1, B equal to 2. All right, but by the way, let me remind everybody, I mentioned to everybody this several times. I'm mentioning one more time. There are corrections on the book that is posted in a document called Corrections in the Textbook. And that document is there in the Blackboard in the supplement section, course supplement section. You need to open that document and make those corrections physically on your book, on your printed book, if you have the printed book. If you don't have the printed book, at least have that document printed and make it available all the time so that whenever you do homework problems, you have the corrections in front of you. Otherwise, you'll be doing the wrong problems. So please do those corrections. And I'm telling you again, because this time in this last assignment also, one or two students didn't do the corrections and they ended up doing the wrong problem and losing points. So I strongly advise you to do that corrections. So in this problem, there were corrections on that on that document, which was the declaration of some variables are missing. The J and K declarations are missing. So they were mentioned in that correction. So you need to make those declarations. Wait 1 second, call this. Okay, so let me go over the problem. So these declarations were added as correction. And also the semicolons are missing in the last 3 statements, and they were also added in the correction. So anyway, I'm going to go over the problem. I has a 4, A has a 1, B has a 2. Now S equal to, so let me write that statement, S equal to 3 over I multiplied by 3. Okay, so it's going to do the 3 over I first because that's in parentheses. 3 is integer, I is integer. It's declared as integer, as you can see. And so 3 over 4 is what that is, and that's a 0. Because 3 over 4 is 3 over 4, the actual value is 0.75, but it's not going to give you that because integer divided by integer is integer. So this is going to be a 0, and you're multiplying by 3, and so the result is 0. But the S is declared as float, and therefore the 0 will be actually 0 point. So S has 0.0. That's the answer to your question. Even if it's 0, you're supposed to have the decimal point added to show that it is a floating point type.
Professor, I don't think when I looked at it, I don't think S was declared as float when I looked into the problem. It says float A equals 1 and B equals 2.
That's here, but you had to look at the correction. So you must have missed the corrections.
Oh, my bad. Okay.
Okay, that's why I tell you, you had to do the corrections, otherwise you'll be doing the wrong problems. Okay, it's not a whole lot. It's a 1.5 page long corrections are there, and you must do that. Okay, otherwise you're going to lose points because you're doing the wrong problems. Anyway, the J, I'm doing the second line, J equal to 3.0 divided by 9, 3.0 divided by 9. See, the 3.0 is written as 3.0 there to make it clear that it is a floating point number there. You're dividing by 9. But when you divide floating point number by integer number, the result will be floating point because they both will be converted to float. So therefore, the result of this is 0.3333 infinitely long, and then you multiply by 3, it'll be back to 1. So it's 1, and depending on some computer may not recognize that as a 1. It may give you 0.99999. But if you mention that as the answer, that is still correct. But 1 is the number most of the time, most likely the computer will come up with. And that would be then converted to float type because J is float type, and therefore J actually has 1.0. Doing the next one, K equal to A plus 2.0 divided by B divided by 2. Okay, so you have to do this arithmetic in the right order. There is a addition, the parentheses will be done first, and inside the parentheses you have an addition and a division. So between addition and division, the division goes first. So this division will be the first operation. 2.0 divided by B, which is 2, will be 1.0. That's a floating point number, 2.0 divided by 2. And you're adding that to A. A has a 1. So that addition will be the next one because it's in parentheses. So that will produce a 2.0. And you're dividing that by 2. The division is this division is the last step. So you divide by 2, it'll be equal to 1.0. So K has 1.0. You must
Okay, I see. I didn't look at the correction. That's why I got it wrong. But I had the right answer, but I didn't have the floating point number for it.
Okay. Yeah, the decimal point is necessary. It is important that you write that. Okay, remember that in all your homeworks and tests. If you don't write the decimal point here, it'll mean K has the integer, which is wrong. And so, you know, you don't lose all of the credits, but you lose partial credit. So if anybody gave me 0 for S and 1 for J and 1 for K, that means you didn't pay attention to the decimal points and you lost a point for that. Okay, anything else?
Nothing else. Thank you.
You're welcome. Okay, then anybody else with any questions? All right, if nothing else, then I'll go on to the discussion problems. The discussion problems I choose are always on the topic that you have just completed watching. And it is always designed to understand the material better and to be prepared for the homework better. So doing these will help you with the homework. I mean, you'll understand better, so you'll do better with the homework problems. All right. Let's see, first question says, can we store a number in a char type variable? In other words, writing something like this, char S equal to 35. Is that valid or not?
Invalid.
You said invalid? No, wrong, valid. There's a section in the lecture that explains to you, not this last lecture, previous lecture, that explains to you that a character type variable can be used to store a number, but the character type variable has only 1 byte of memory, and therefore your number is limited. The number you can store in a character type variable is limited. And we even calculated the largest number that fits in 1 byte of memory. Anybody remembers the largest number that fits in 1 byte of memory?
It's 256.
255 bytes.
Oh,
255 is the number, yes.
Oh, sorry.
Yeah, 255.
255 is the largest number that fits in 1 byte of memory. So if you declare a variable as char S, and you assign a number to that S, then 255 is the largest you can fit in there. If you assign any other number, is it going to fail? The program is not going to fail. If you store a larger number like this, if you say it's equal to 355, system is not going to find that as an error. It's going to go ahead and work with it and produce an answer. Now, what's the problem? The 355 doesn't fit means it'll just fit the bits that can fit. So let me just explain using some examples. So let's say you translate the 355 to binary code and you get something like this. I'm just making up a code. It's going to be more than 8 bits, right? So it's going to be, let's see, 4, 8, 9. Yeah, I have 9 bits here. So it's going to be something like this. It'll have 9 bits. So if you have 9 bits and you only have 1 byte of memory available, it's only going to store the last 8 bits for you. That means you have a wrong number stored in there. And why is this doing it? Why can't we get error message in this case? Well, there's a reason. The language is designed to handle anything the programmer wants to do. So this is something that programmers sometimes want to do in advanced programming situation. The programmer wants to get the bits truncated, you know, whatever the ASCII, whatever the binary code of the number is, the programmer sometimes wants to store only the last 8 bits in a memory and drop the other ones. So that's called truncating the code. And that has to be allowed by the language because programmers sometimes need to do that. So that's why it doesn't give you error. It thinks that you want to drop that bit and you only store only 8 bits. And that's why it's doing it. So what happens is you have a program that's going to produce wrong answer. If this was intentional, that would be different. But here it's not intentional. You know, you're trying to store a large number that doesn't fit. So numbers that don't fit, if you assign them to variable, it will just store the part of the binary code, and that means you're going to get wrong answer. So if there's a program that's going to produce wrong answer, then that should be your answer. In one of your homework problems, more than one of the homework problems, it asks you what is your output. Not in this particular one, but as we proceed, you will be running into those homework problems. What is the output of this program? So if the output is going to be a number, then you provide that number. If the program is going to fail, then you say it'll fail, there'll be error message, and then you explain what the error message is. If the program is going to produce a wrong answer, then that's what you're supposed to say. You're not supposed to produce the wrong answer and say this is the output. You can't even figure out exactly what the wrong answer will be. See, in this case, instead of 355, it's going to store some other number. And if you see out the S, that other number will be printed. And you don't know, exactly what that number is. So you're supposed to say, just this program is going to produce a wrong answer, simply wrong answer. That's how you answer that. So that's one of the discussions in this lecture, in the last lecture you watched, in which situations the program will produce wrong results. And you're supposed to learn all that. So there are conversions going on, and because of that, sometimes program will fail, or if you store a number that doesn't fit in the memory, then the program will fail. It'll produce wrong answer. I mean, not fail, it'll produce wrong answer. So you're supposed to identify those situations. That's what this pretty much today's discussion is going to be. So we can store a number in the chart type variable, but the number has to be limited to number should be smaller than 255. So can we do calculation with char? Yes, I explained to you in the last class that you can do arithmetic with the characters. So I can even do this char. Even if I store characters, char x equal to b in quotes, comma y equal to c in quotes, and then I can say int z equal to x plus y. Then I'm adding x and y. They are both characters. Can we do that? Yes, we can do that. So whenever when it sees plus, it knows you are referring to the decimal equivalent. So it'll use B is 66 and C is 67. So that's what it's going to add. And it'll store that in Z. So yes, we can do calculations, arithmetic with characters. We can store numbers in the character variables and do arithmetic with them, or even characters in the character variables and do arithmetic with them. They are all valid. Okay, so the first question is finished. Now let's go to the second question. What is the largest number that fits in a variable declared as short val and then unsigned short val? Can somebody, if you remember, we calculated the largest number that fits in short type variable. You don't really have to memorize them, but if you remember them, it'll be helpful. So anybody remembers the largest number that fits in short type? Short type variable gets 2 bytes of memory. So if I declare variable val as short, short is same as short int. You don't have to write short int. You can just write short. Then it's going to get 2 bytes of memory. And so we can figure out the largest number that fits in 2 bytes of memory. It's going to be 8 ones in the first and then 8 ones in the second. Okay, now you have to translate that to binary number. I mean decimal number. This is the binary. This is the largest binary number that fits in that memory. So this last one corresponds to 2 to the 0, 2 to the 1, all the way to, see, this bit corresponds to 2 to the 7. And then this corresponds to 2 to the 8. And so there are 16 bits, so there will be 2 to the 15 will be the largest power. And to figure out the sum of this series, I gave you a formula. Apply that formula. Can somebody tell me what the value of this summation is by applying the formula?
It would be 2 to the 17th.
2 to the 16. One more than this power. 16.
Yeah. Would it be, are you talking about the 2 to the n plus 1 or no?
Yes, 2 to the n plus 1.
So it'd be 16 plus 1, right?
15 plus 1.
Minus n.
15 plus 1 minus 1. This 15 plus 1 is the 16. And then you have to subtract 1. So let me write that formula again down here. 2 to the 0 plus 2 to the 1 all the way to 2 to the power n is equal to 2 to the n plus 1 minus 1. That's your formula. Okay. And you need to remember this formula. It's a geometric series. You know, if I forget this formula, I can immediately calculate this because I know geometric series. But if you didn't learn geometric series, then just memorize this formula. That's all you need to do. Anyway, so because it's 2 to the 15 is the largest power, 15 plus 1, 16 will be in the power of the answer, and then subtract 1. And if you calculate 2 to the 16 in the calculator, so you're going to need a calculator with the exponent button to be able to do this. I sent you an announcement yesterday about the test. The test will be Wednesday next week. And you need to do the practice test found on the web Blackboard in the course supplement area. You need to do that before next Monday and bring up questions on Monday. Monday, I'm going to take questions on the practice tests, and that's how we prepare for the exam. The exam will be on Wednesday. We'll talk about the exam a little more later, but I just wanted to remind you that you need a calculator for this exam, and you cannot use the phone. You cannot have the phone in front of you at all for the test. The only way you can have the phone is if you need to use the video, use the phone to show the video of you taking the test, because I have to see everyone who is taking the test. So everybody's video must be on. So if there is any reason your video cannot work, if you have the video on your monitor, or you don't have a video, all the monitors nowadays have the video camera. So anyway, if that doesn't work or something, then you can use the phone to show the video. You can join the meeting in the phone, then I'll be able to see the video. So you can use the phone for that purpose. You cannot use the phone for any other purpose, and therefore you need a calculator. So scientific calculators are not expensive anymore. They're in dollar shops now. You can buy them for $1, scientific calculator. So please get one before the exam. You're going to need one, and I will not be able to help you during the exam if you don't have a calculator. Okay, so 2 to the 16 can be calculated in your calculator, and that'll be 65,536, and you subtract 1, 65,535. That's the largest number that fits in the 2 bytes. So if you remember this number, it'll be helpful to recognize when your result, your actual answer is too big to fit in the memory. Only if you remember this, then it'll be immediate. Otherwise, you had to calculate this number first and compare it to figure out whether the program is going to work or not. So at least these, the largest number that fits in 1 byte and 2 bytes. If you can remember just those, it'll be helpful. Okay, now what is the largest number that fits in a variable declared as unsigned short int? So there's a small difference in the unsigned short int. You learned in the video that when the variable is declared as unsigned, in this case it's short, but it can be unsigned int, unsigned. There's no unsigned char. That's because char cannot accept negative numbers, because char can only take the numbers in the range 0 to 255. So there is no negative number, and that's why there's no unsigned char. But unsigned short, unsigned int, all can be possible. So if I declare a variable as unsigned short val, then I have 2 bytes, but I don't have all 16 bits available. 1 bit is I'm sorry. Sorry about this mix-up here. I apologize. What I went through here is for unsigned short. Only when you declare the variable as unsigned short, you have all the 16 bits available for your number. That's when the largest number that fits is 65,535. Only if it is unsigned short val. If it is declares as just short val, then it's not unsigned. That means you're allowing sign. So when you allow sign, 1 bit is reserved for the sign. So therefore, you only have 15 bits available to store the number. So I'm going to show you how to calculate that number. So it'll be 8 ones in the second bit, and only 7 ones in the first bit, because the 8th bit is sign bit. So you want to evaluate this number in decimal form. So then it's 2 to the 0 plus 2 to the 1 all the way to 2 to the power what?
14.
14 is correct. Very good. 2 to the 14. So applying the formula, what is it equal to? The series is 2 to the 0, from 2 to the 0 to 2 to the 14. So apply.
So it'd be 16,383.
Oh, I meant to ask you to tell me the result of applying formula.
Oh, sorry.
Yeah, 2 to the
Would it
power.
32,767.
That's right, but I'm not asking for the number. I'm asking you what you get when you apply the formula. 2 to the power of what? When you apply the formula to this series,
2
what?
to the 14th minus 1.
15 minus 1. Yeah, that's all I asked you. Okay, so some of you calculated the value 32,000 something. That's correct. But I can quickly calculate that myself to confirm. The calculator in your phone is a scientific calculator. It's adequate, but unfortunately, I cannot allow your calculator because I don't know what I cannot allow your phone because I wouldn't be able to see what you're doing with the phone. The phone is a device for all kinds of things. So that's why the phone is not allowed because, let's see, because it can be used for cheating. Hold on, wait. Okay. All right, I'm calculating 2 to the power 15. 2 to the power 15. Yeah, 32,768, and you had to subtract 1, 32,767. Okay, you don't have to memorize all these numbers. Only the 255 and the 65,535, those two are helpful if you remember, but any other number you don't need to memorize. So this number, but you have to be able to calculate that. It's a problem in the test can ask you, a variable is declared as short val. Now, what is the largest number that can fit in here? Then your answer is 32,767. So if it's a test question, you're not showing any work, you're just showing the answer. You are allowed to have a sheet of paper to do the work, and then you enter the answer. Okay, so all these different largest numbers, you have to be able to calculate that. So another question can be unsigned short int. A variable is declared as unsigned short int. What is the largest number that fits there? A variable is declared as short int. I'm sorry, a variable is declared as int, just int, no unsigned. Then there is signed bit. So you have to be able to calculate the largest number that fits in there. Okay, so our answer to the part A is 32,767. And answer to the part B is 65,535. Okay, question 3. Can we declare a variable as unsigned char val? Can we do that? I think I answered that question earlier.
Yes.
No, because char doesn't allow sign, so there is no reason to declare unsigned. A char type variable allows only the numbers in the range 0 to 255. You cannot store a negative number in it. So if you store a negative number, you'll get error message. Char variable cannot handle negative number because it's designed to handle characters, and all the characters correspond to positive numbers. So that's why char type is designed to allow only positive numbers. So So we cannot declare unsigned. We cannot use the word keyword unsigned with the char. Okay, number 4. Let me enlarge this so that you can read better. All right. Number 4. Is there anything wrong with this program? Can this program work properly, or anything wrong?
I'd say no, because they're different variables.
You mean it cannot work properly? Is that what you're saying?
Yeah.
Okay, and your explanation is?
Because they're different data types.
Different data types. In an arithmetic operation, the two variables can be of different type, right?
Oh wait, no, it's just that char isn't it's not a character. There's a integer in there.
I just explained a few minutes ago, you can store.
Oh, right.
Okay, integer can go in a character variable.
This is supposed to be a variable like defining the W times X.
Yeah, the data type of it.
Yeah, what's the data type of the product? That's the other next question. That's a part of the problem. So is it going to work right? You have to answer yes or no. If you say yes, then what's the data type of the output? If you say no, you have to explain why. So for the answer question first is it a yes or no? The question is this program going to work and produce correct results? Yes or no? The answer is yes. Because there's no problem. I'm multiplying character variable, which has 175, and an integer variable, which has 186. But one is character, the other is integer. If both are characters, we will have a problem. But since the second one is integer, there's no problem because they both will be converted to larger type. The larger type is integer here, right? So the W will be converted to integer, and then the product will be calculated, and the product will be integer type. All right, I just answered the question. Answer to the first question is yes, it'll work. And the second answer to the second question is it'll be in type. Any question on that? Okay. Now let me ask.
It'll be in type because you're multiplying integer by integer, right?
It'll be in type because yes, the value of W will be converted to integer. And because when you have in any arithmetic operation, if the two variables, two operands are of different type, then both will be converted to the larger type. So the larger type in this case is integer. So therefore, the character will be converted to integer and they will be multiplied and the result will be integer. So the result will be the same type as the larger one in the operation. All right, you got that?
Yeah.
Okay, now let me make a variation. Char. Do we have a problem now? The same questions. I want you to answer now.
It'll be an error.
Okay, one student says there will be an error. Any other answer? Okay, if your conclusion is error, then you have to explain. That's how the homework problem or test question it'll say, if you say error, then explain why. If you say no error, then what's the data type of the answer?
Because when you're multiplying chart type by chart type, in this case, you'll get an integer. So wouldn't that be an error?
I explained a few minutes ago, you can do arithmetic with characters, right? So it'll, yeah, it'll multiply those two numbers. There's no, even if you store a character here, it'll do the multiplication of the characters. So you can do arithmetic with characters. So why is this, okay, so why is there an error? Characters can be multiplied and it'll produce a number.
It wouldn't be able to be stored, from what I understand. Is that what you're saying?
Well, you're almost there, but it's not complete answer.
Okay.
Yeah, it cannot be stored where, why?
It wouldn't be stored as a character type?
Yeah, they're both character types, and then you're multiplying the characters. Like I said earlier, multiplication, addition, anything can be done with characters. There's no issue with that. So your answer was error. That is incorrect. There will be no error. This program will run, and it'll produce a number, but that number will be wrong. So your conclusion should be wrong results. The program will produce wrong results. So in that case, you're supposed to write wrong result as your conclusion. And let me explain why. The 175 and the 186, you're multiplying. So they're both chart type. So when they're both chart type, the result has to be stored in a chart type's memory. There's no conversion. You're not doing any conversion here. So when you multiply the two numbers, it'll automatically allocate, if they are both of the same type, the char type multiplied by char means you're multiplying two 1 byte type numbers. So it'll allocate, it'll take the result as a char, and the result will be going in a 1 byte memory. It'll allocate only 1 byte memory. See, remember, the system is allocating memory now for the answer, because you didn't declare a variable to store the answer. So in this case, the answer has to be stored by a memory selected by the system, and it's going to choose only 1 byte of memory. And if you actually multiply 175 by 186, that's clearly bigger than 255, right? So it's not going to fit in 1 byte. And therefore, wrong results will be produced. It'll print a number for you, but it's not going to be a wrong answer. There will be no error message. So I explained earlier why the system the language is designed to allow this. You know, why can't we get error message? I explained to you before, because people do this. Programmers sometimes do this intentionally, and that's why it's allowed. But for our purposes, our intention is to get the right numbers here, and it's not going to get that. If anybody is unclear, please ask the question. All right, going on to number 5. Now, let me put that back to int. So if one of them is an int, then everything is going to be fine, because the answer is going to be now int, and the resulting number will fit in a 4 byte memory. Int gets 4 byte memory, so the result will fit in a 4 byte memory, and there's no problem. But when when they are both chars, we have a problem. Okay, problem 5. So read that and see if you can answer the question. Nobody has an answer for that? Number
This
5.
should, this should be executed, right? Because it will be an integer type result.
The variable m is integer type, yes. So your answer is it's going to work fine?
Yeah, that's what I think it is, because I got an integer as a result.
Okay, any other answer? Neil thinks it's going to work and produce the right results. Okay, no one else has an answer. All right. No, Neil, you're incorrect because this program will not produce correct answer. It's going to produce an answer that's going to be wrong. So let me explain why. You have to look at this statement, int m equal to x plus y. Just because the left side is integer doesn't mean this will produce integer answer. You're adding x and y, which are both chars. So when it does this arithmetic operation, it's going to store the result in a char type memory, and then whatever that is stored here will be assigned to m. The operations in an assignment statement, there are 2 steps in the operation. One is doing the arithmetic first, and then that result will be then assigned. So when it is doing the arithmetic, it's going to store the result in a char type because they're both char type. X and Y are char type. So the result will be char type, right? You remember that. So it's going to use the char type memory to store the answer. When it does the work, it's going to have to store the answer somewhere. And there is no, so that's why when the variable types are matching, the result will be of that type, means a data type, a memory will be assigned to that type, and the answer will be stored there temporarily. And that answer will be then assigned to m. So there are 2 steps. So when you do this arithmetic, the result is going to go in a 1-byte memory, and the result is actually bigger than 255. You see that, right? 198 plus 75 is bigger than 255. So it's not going to fit in 1-byte memory. So it'll just store whatever that can be stored in the 8 bits, which is going to be a wrong number. And when you now assign it to m, even though m has larger memory, the damage is already done during the operation. You already.
Oh, because the char only accepts 255 in 1 byte.
Right. Then you
Okay,
add,
okay.
yeah, when you add these numbers, the result is bigger than 255, and so only 1-byte memory is allocated to store the result, and so you don't have the correct number stored in there. So having an integer variable on the left is not going to help. You have to look at the operation and the operands, and if the operands are both char type, the result will be char type, and that is where the problem is. And this in the section 2. Near the end of 2.3, the focus was on these overflow situations. Overflow situation, in other languages, overflow situation is handled as an error. So you get error message in some other languages, but in C++ you don't. So that's why you had to understand this. You had to pay attention seriously here to the operation and make sure that operation is going to produce the right results. Okay, now problem 6 has 2 parts, and you need to write the output of the. So this kind of question you have done in your homework, and you will be doing everywhere throughout the course. A little code will be given, and you decide what the output will be. And when you conclude that the program will not run, it will produce an error message. You need to explain why. If you conclude that program will run and produce wrong answer, again, you need to explain why. You need to write wrong answer as the conclusion. And in homework, you'll be asked to explain, but in the test, you may not be asked to explain. 1 second. Okay, so for part A, anybody has, well, I'll give you a few minutes to read through and figure out what the result will be. If anybody has an answer for A, go ahead.
Would it be 24.0?
Okay, 24.0. So output for A, Neil says 24.0. Any other answer? Okay, Neil, go ahead and work on the second problem while I'm waiting for the others to come up with an answer. Nobody else can find the answer for part A?
I got the same answer.
Okay. And that's Kevin. Okay. Kevin has the same answer. Very good. I mean, two people are answering. That's good.
I have the same answer as well.
Okay. 3 students have the same answer. Anyone else?
I got 24.0.
Okay. 24.0. 4 students have the same answer.
Yeah, 24.0.
Okay. Carlos has the same answer. Okay, I'll tell you that 24.0 is wrong answer. So take another look at it again.
Is it incorrect because const is after float?
No, that's
Okay.
correct.
Okay.
You can write const float or float const. That's right.
Oh, okay.
Can anybody see why 24.0 is wrong?
Oh, is it because X is a constant?
X is a?
Yeah, X is a float constant
Okay, X is a
variable, so it won't.
Oh, so X is a constant. So what's the problem?
Since X is a constant, you can't. It won't produce a proper result.
It's
You
well,
can't change the value.
you cannot change the value of a constant. You're trying to store a number in X. X already has a 4.5. You cannot replace that 4.5 with something else. So it's not, you said it cannot produce right results. No, it cannot produce anything. You'll get an error message. All right. Because the program is trying to change a constant to a different number, that cannot be done. That's not allowed. Okay, everybody understand the answer now?
Yes.
All right, part B.
Wouldn't it be an error?
Error, why?
Because it can't be stored in it.
Can't be stored in 1 byte of memory.
What
It
cannot
can't
be stored where?
in the bytes.
Uh,
From what I understand, you said that when it would take out some bytes, it would take out some numbers because it can't be stored in it.
Some
So
of the-
that's an error. It would come out with error.
yeah, so that's not error. That's,
I give you the wrong answer, which in
yeah,
turn
you're
is
wrong,
error.
wrong answer, right? So don't use the wrong word when you're answering question. If you say error, that means the program will produce an error message, and then that means program will not work. This part A, that's the situation. There'll be error message, your program will not even run. Part B, the program will run. It'll produce wrong answer. Okay, so you had to say it that way. I think you had the right answer in your mind, but you didn't say it properly.
I'm bad at explaining things, but I know what it meant.
Okay. So when you're answering these questions in your homework or test, think second time and use the right word. So part A, the answer you provide in the output section is error. And for part B, the correct answer is wrong.
Wrong answer,
Yes.
because the result is larger than 255.
Yeah,
the
the
chart,
result is
chart
larger
type.
than 255, and therefore only the bits that would fit in 8-bit long memory will be stored, which means you're dropping some of the bits, which means you're getting wrong number. So the result will be wrong. That's the answer to this question. And if the problem asks you to explain, then you have to explain. In the explanation for the part A is constant cannot be changed. Explanation for part B is m times n is too big to fit in 1 byte of memory. Okay, problem 7 says write program that multiplies 175 and 35. So last question. Okay. Basically, you need to decide what type of variables you need to use, what data type you need to use, because the problem says you need to multiply these numbers and use least amount of memory. So that means you're not free to
Will
use.
it be chart type?
Okay, so you declare chart type. All right, let me write. Char x equal to 175, y equal to 35, semicolon. And what should be the next step? Now, anybody feels that this is not going the right way, then let me know. What do you think, Neil? Neil, what do you think the next line should be? You need a variable to store the answer, right?
Yeah, so would it be, I don't know if this is correct, but would it be int?
Int z equal to
X
X.
times Y?
Times y. Everybody agree with this, or anybody has a
I
problem?
think this is
Why
wrong,
did
but
that not work out? Because it's a chart. Or wait,
Okay, Gina, you think it cannot work? Then explain.
because 175 times 35, it would be too big.
Too big to fit in a chart type memory, right?
It's gonna be a chart, and
yeah,
you would put it in the in. Doesn't make
Okay.
sense.
Then what should be the data type then?
Wouldn't I put int instead?
Int will get 4 bytes, then you're using too much memory, aren't you?
Okay.
We're supposed to use least amount of memory. You're supposed to use least amount of memory, right? So
See
Uh,
out,
go ahead.
see out 175 times 35.
No, you cannot do that. You have to store the data in variables before
Okay.
writing multiplication.
And float would be too much, right? Cause that's 4 bytes, right?
Yes, float will get 4 bytes. That's too much. We don't need 4 bytes.
So would it be, will you subtract that to get the 1 bytes of memory?
Subtract what? You cannot take float and subtract some parts of the memory. If you declare float, you're going to get 4 bytes. You cannot change that. So basically, int and float are too big, too much memory. Problem says we need to use least amount of memory. So what would be the right data type is the question.
Would
Yeah.
you use short instead?
Short is correct. Short is the right one. Short x equal to 175. Now, the 175, 35, they both fit in char type, but we cannot use char type because the answer is too big to fit in char type. So if you're declaring one of them short and the other one char, that will be correct because the answer will be short type, but there is no use of that. So short x equal to 175 and make the other one also short, because when the system is multiplying, it's going to convert both of them to the same type. So having one of them declared as char is not going to help. It's going to be converted to short anyway. So therefore, make them both short. It will be easier for you, and there's no loss of anything. So 35 will be also short type, and declare the z also short type, and z equal to x times y, and see out z. Now you're using least amount of memory, and the program will produce the right results, because 175 times 35 fits in short type memory. All right. Okay, so I hope that helped understand everything. Now, these are critical matters that when you're doing a problem, you need to pay attention to whether the answer fits in the memory allocated for the answer, just by looking at the multiplication. Remember, having a large enough variable on the left side is not going to help. The operation itself has to be stored in that data type. So you need to pay attention to that to answer questions like this. So there are questions like this in your homework, in your test, and you have to pay attention to those details. All right, so that's all the problems we needed to go over today. So I hope that helps you understand better. Unless you have any more questions, we can close at this point. Any other question anywhere? All right,
Can you explain number 5 one more time?
number 5. All right. Okay. Okay. The answer here is the program will produce wrong results. And let me explain. When the char type variable x and y both are char, and when you add x plus y, 198 plus 75 is 273, and that's bigger than 255, right? So, but when you add, when this addition is done, when this statement is executed, int m equal to x plus y, the x is char type, y is char type. So when it does this operation, the result will be stored in a chart type memory. Temporarily, the system has to choose memories to store the answer when the operation is done. And that will be a chart type memory, 1 byte. So this 273 doesn't fit in here. Okay, so if 273 has these bits, obviously it's going to have more than 8 bits. Uh, 4, 7, 8, 4, 8. Okay, so 9 bits. This 273 is going to have 9 bits. So what you're doing is you're going to be storing this many bits in here because 9 bits are not going to fit. And whatever that number is, the decimal equivalent of that number is what you're storing. You're not storing the entire number. So when you assign it to M, this stored number is going to be assigned to M, not the actual number. See, when you did the operation, the answer has to go somewhere first, and then it will be copied into M during the assignment. So the answer goes into 1 byte of memory, which is going to be wrong answer because you're losing a bit. So we don't know, we cannot tell what that number is. We can tell if you calculate the binary code of 273, I think you can figure out what the wrong answer will be. But there is no point. We don't need to figure out the wrong answer. There will be a wrong answer. That's all we need to say. Okay. So the operation produces wrong number, and that will be copied into M, which means program produces wrong answer. All right. Understand that now?
Yeah, I understand it now.
Okay.
So is number 5 and 4 similar then?
Similar, yes. My problem 4 originally had int x. If you have int x, it's going to be fine. The way it is written right now, this problem number 4, the way it is written is going to be.
Oh, because it's being stored in the integer type,
Yes.
which requires 4 bytes.
Yes, the result will now go into an int type memory, 4 byte long, because one of them is int. But if I make the int a char, then it won't produce correct results.
Then it'll be wrong results.
Right, wrong results. With the int, it'll be correct. It'll produce right results. Okay. Any other question?
And one more question, can you explain the short vowel and the unassigned vowel one quick moment? Because I was confused with that.
Short and the, okay. If you declare something as short vowel, if you declare that, then you are allowing sign bit. So there'll be 2 bytes of memory. Anytime you declare anything as short, 2 bytes of memory will be allocated. And when you declare short without the unsigned, you're allowing sign. So the number that you're storing in val can be negative. It's allowed to be negative. So therefore, system has to allow 1 bit for sign. It's not exactly storing a minus in the sign bit or plus. It's handled in a different way, but that's you're not ready to understand those processes. When you go, I mean, if you're a computer science major, you will learn that in a more advanced course where they will explain exactly how negative numbers are handled. There is no negative sign. We cannot store the negative sign. So the number is kind of converted to something else. And that process will be explained in an advanced computer science class. But the point is, you still need 1 bit to store something that makes this number negative or positive. So that we call that sign bit. So there's a sign bit that cannot be used to store the number. So the number can be stored only in the remaining bits. So the largest number that fits in here will have 8 bits in the second byte, only 7 bits in the first byte. Only 7. So therefore, the largest number is equal to 2 to the 0 plus 2 to the 1 all the way to not 2 to the 15, it's 2 to the
It would
14,
be 2 to the 14th, right?
2 to the 14 now, right? Which is equal to 2 to the 15 minus 1, which is 32,000 something. But if it is declared as unsigned short val, then you have all of the 16 bits available to store the number. You can only store positive numbers now, no negative numbers. You do this only if your data are all positive. Okay, then you have all 16 bits available. So you have 16 ones in the largest number that fits in here. That means 2 to the 0 to 2 to the 15, which gives you 2 to the 16 minus 1. Much larger number, almost double. Actually, more than double. Anyway, this one is 65,535. So that's what it is. Short val and unsigned short val. The largest number that can be stored are very different. Okay, you got it?
Yeah.
All right. Anybody else, anything else? All right, then we'll quit now.